In this video, I'd like to talk about the math question of the day for Thursday, July 6th, 2023. And with this problem, we need to factor completely this product of these two polynomials, specifically these two quadratic polynomials or second degree polynomials. And factoring techniques are typically taught in an Algebra 2 class, though you might learn some in Algebra 1 specifically related to quadratic polynomials. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And the general strategy is to focus on each of these quadratic polynomials separately, and we can factor them individually. And if we focus on this one on the left, this 3x squared minus 12x, with factoring, we can always start by trying to factor out the greatest common factor. It doesn't always work, like in this quadratic here, it will not work, but in this one it will. We can ask ourselves, what is the greatest factor that would divide evenly into both of these terms? And we can see they're both divisible by 3, and they're both divisible by x. So we can factor out a 3x, and here we're just left with an x, and here we're left with minus 4. And of course, you can always check these by just redistributing and see if you get back what you started with. So this one factors into 3x multiplied by x minus 4. And now we can look at our second quadratic here, x squared minus 2x plus 1. And this quadratic, we cannot factor out a greatest common factor. The only number that divides into all three of these evenly is 1, so factoring 1 out won't help us. But we can factor this most likely into a product of two binomials. This does not always work, but usually these problems are crafted so that it is factorable. So we can at least attempt it. We know that with these binomials, they each have two terms. And we know the first terms have to multiply to x squared. The first one's in each of these, so these have to be x and x. Since if we remultiply this out, when we distribute, we'll get x times x, which is x squared, the highest power term. Now, these two missing constants here and here, these have to multiply to positive 1, though they will also add to negative 2. So we can write out the factor pairs for 1. We know that, well, 1 times 1 is 1, or negative 1 times by negative 1 is 1. But they have to add to negative 2. So it's our second choice here, x minus 1. Let me rewrite that. And multiplied by x minus 1. And again, once you think you factored this correctly, you can check by redistributing. Redistribute the x to each of these, you get x squared minus 1x. Then you do it with the negative 1, you get minus 1x. And minus 1 times minus 1 is positive 1. And since you had minus 1x twice, that's really just minus 2x. So it does simplify back to what we started with. So we can feel confident that this is factored correctly. And now just combining everything together, this product of these two polynomials would factor into 3x multiplied by x minus 4, and then multiplied by x minus 1 twice, which we can write as x minus 1 squared. So this right here should be our final answer. And if you do want to check it, just re-multiply everything back out and see if you get back what you started with.